back-end proxy were mesmerizing. As the lead technical product manager for Logil's Cloud Architect Trainer, she knew exactly what those spikes meant. A user had just clicked a MathFlow concept card. The traditional learning management system LMS industry had been stagnant for a decade. Video tutorials, static PowerPoints, and multiple-choice quizzes designed in 2014 still dominated the multi-million-dollar certification prep market. DevX developer experience was practically non-existent. When Logil decided to build the ultimate cloud architect trainer covering the AWS SAAC 03, SAP C02, and GCP PCA tracks, Sarah drew a hard line in the sand. No static content. Every single one of the 1,000 concepts in their curriculum had to be uniquely generated, animated, and mapped to a real-world engineering architecture. The problem? Hand-coding 1,000 unique architectural states with proper variables, mermaid. JS diagrams, markdown trade-offs, and Terraform implementations would take an engineering team of 20 people, roughly 4 years. So they didn't. They built an AI-driven just-in-time JIT generation subsystem. Now the system was live, and Alex was staring at it, too. The glassmorphic canvas. Alex the architect, a prominent DevOps influencer with 250,000 subscribers and an aggressive intolerance for fluff, clicked his mouse. He was currently testing the platform from his dark, LED-lit studio. He had navigated through the central hub UI. The sidebar was clean. He saw his XP bar Cloud Novice 050 XP. He triggered the next module in Phase 1 CC-8016 VPC peering architectures. The URL flipped to MathFlow. Card CC-8016. The moment his browser requested the DOM, an invisible JavaScript observer kicked in. Cloudflow. JS initiated a sub-millisecond ping to the backend SQLite server, searching for the concepts. JSON payload mapped to CC-8016. The database returned a payload, but it was hollow. It only contained a title and a placeholder description. The array for transformations was empty. The visual logic engine had nothing to render. Alex leaned closer to his monitor, expecting a 404 error or a generic coming soon page. Instead, the screen shifted. A seamless, dark, frosted glass overlay slid over the UI viewport. The backdrop filter Blurtwell PX CSS parameter organically melted the rigid background structures into a soft, professional blur. In the dead center, a pulsing, minimalist, glowing ring appeared. Beneath it, the strict JetBrains monofont snapped into place, generating high-fidelity architecture schema via OpenAI. This structural compilation may take 8-15 seconds. Wait, Alex muttered to his empty room, adjusting his headset. It's writing the course material right now. 3. The 8-second synthesis. Behind the glass UI, absolute chaos was. concept card CC-8023. Argo CD is a declarative GitOps continuous delivery tool for Kubernetes. It enables developers to automate the deployment of applications by leveraging Git repositories as the single source of truth for defining the desired state of Kubernetes applications. Argo CD is designed to help teams adopt GitOps practices, ensuring that the deployment process is streamlined, auditable, and efficient. Phase header 8. Concept card CC-8022, GitOps in retail business. In the context of a retail business, GitOps can be likened to a sophisticated inventory management system that ensures all stores operate with the same up-to-date product information and pricing. Imagine a retail chain with multiple locations, each needing to manage inventory levels, product details, and pricing strategies efficiently and consistently. Retail business analogy 1. Single source of truth. Just as Git repositories act as the single source of truth for application configurations, in a retail environment, the central inventory management system serves as the authoritative source for all product-related information. For instance, when a new product is added or a pricing adjustment is made, it is updated in this central system. 2. Declarative infrastructure. In a GitOps model, changes are made declaratively, meaning that the desired state is defined and stored in Git. In retail, this could translate to defining the desired inventory levels for each product across different stores. For example, if a store needs 50 units of a specific product, this requirement is documented in the central system. 3. Automated synchronization. Similar to how Argo CD automatically synchronizes the state of Kubernetes applications with their Git configurations, the retail inventory management system can automatically update each store's stock levels based on the central inventory. If a store sells 10 units of a product, the central system adjusts the inventory level accordingly, triggering restocking processes if necessary. 4. Version control and rollbacks. Just as Git allows developers to revert to previous versions of an application's configuration, the retail system can maintain a history of inventory changes. If a pricing error occurs, the store can Concept card CC-8025. Blue-green deployment case. Blue-green deployment is a strategy for application deployment that reduces downtime and risk by running two identical production environments, referred to as the blue and green environments. This method allows for seamless transitions between different application versions while ensuring that users experience minimal disruption. Unlike traditional deployments, which are best suited for stateless applications, stateful sets provide guarantees about the ordering and uniqueness of pods. This makes them essential for deploying applications that require persistent storage and stable network identity.